All right, just want to welcome everyone to this Pitsco plus ESUCC robotics support for secondary. So we're talking today about grades 9 through 12 as part of a series that we put together of webinars that feature both representatives from Pitsco. They're going to talk to you a little bit about the device, the solution that you purchased. Along with having one of our ESU colleagues. And so thank you, Nick Ziegler of ESU5 for joining us to talk about where those solutions might meet what we do in Nebraska in our classrooms. And so with that being said, again, the conversation today focusing on 9 through 12. If you're looking for information about the other purchases at other grade levels, check out the site that you're likely viewing this through. And if not, we'll get to where all those resources are in due time. But first, Preston, Steph, Nick, thanks for joining us today.
Thank you.
Thanks for
having us. And Preston, maybe I'll ask you first here. We've really had the opportunity to go back and forth in the development of a support site that folks can access. And so again, you might be viewing this through the site, but if not, this would be where we'd point you to. And so do you want to talk us through that support site very quickly before we get into our 9 through 12, as that'll give people a place to go for some help?
Yeah, for sure. And so that site that was just listed below, we've actually here at Pitsco created a one-stop location for everything that you're going to need regarding materials, the products and the solutions that you could have selected as part of that initiative is all on this one website on this landing page that we have created, anywhere from product resources to learning resources, all the way down to where you can contact our order and tech support teams if you had any additional questions there as well. And then also my contact information. I'm the education advisor for Nebraska. And so if you have any questions along the way as well, I'm here to help you in on that journey also. And then also at the very bottom, we included another section to where it says, I'm actually going to be at the Spring NEDA conference, booth 509. It's going to have all my information there. There will be a giveaway inside the booth as well. But just there, this site is just going to be your one-stop shop, if you want to call it, for everything related to this initiative inside the state of Nebraska. So this is going to be shared out throughout the state. I hope you find it helpful. It's going to be a good resource for you all.
Yeah, and maybe, Steph, I would ask, could we go a little bit deeper into some of the things when you go to an individual, let's just pick the Tetrix Max, since we're going to be talking about that today. To walk us through what is on this site for those that are looking for support. It's pretty, not only is it easy, but it's pretty comprehensive.
Absolutely. So when you click on each of the individual solutions that you could have selected, and you scroll down, you'll see several tabs. So one of the tabs will be resources. So if there's any users guides, video resources that have been developed around the solutions that you're using, any getting started guides, build guides, how to out of the box videos, any tips and tricks videos that have been developed around that solution, you will find that on that page. So to give an example, if you would go back and click on the Tetrix Max dual control set. So if you scroll down, you'll see several tabs, resources, videos, any kind of specifications. As you scroll down, you'll start to see if there's any like tips and trick videos, any software that has to be downloaded, any libraries that need to be downloaded within the software. All of those resources are going to be able to be found there. So as you're thinking about unboxing and getting things going, and where do you need to start, going to this page that's been created that specifically call out the solutions from the catalog, you'll be able to go there. If there's software needed, it'll guide you to where you go to access the software. If there's a getting started guide, that'll be there. If you're working through and you running into any kind of questions or challenges, there will be resource videos if you're wanting to learn more about a specific part or piece or how they work together, specifically around Tetrix Max. You're most likely going to find some type of video, how-to video incorporated there. So really intended to have all the resources available to you so that as you're working through and you run into where you have a question or where do I have this, go to that page, click on your solution, and the resources will be there.
And also, Andrew, on that resource page as well, all the webinars that we have been recording are going to be housed on there as well. And then there's also going to be an additional section on all the device compatibility. So let's say you have the Tetrix Max kit and you want to know what kind of device is compatible with that. We're going to list all of that information on that page as well. And so we're adding to it, but it's live and ready to go for you guys.
Yes.
Well, terrific. And we're really grateful to Pitsco for not only your support throughout the purchasing process, but also this follow-up to make sure that we're able to implement these solutions into the Nebraska classrooms and can enhance our learning in those spaces. And so, it's great that we pointed to the Tetrix Max right from the get, because that's where we're going to start today. So we're going to look at that. And I'm going to bring up here on the screen, actually, the catalog that if you were the person who made the purchase in Nebraska, you likely remember seeing this page. And so we're just going to go through and talk about each of the different pieces that kind of go with in support of, or ways to enhance this first piece here, the Tetrix Max.
Yep. So the Tetrix Max is a build system that is utilized in a robotics or a coding course as the hands-on component to it. And then what you build around it is kind of the ecosystem, depending on the class that you're wanting to incorporate it into. Two things to talk about with Tetrix Max is the building system itself is used in 2 competitions. So if you're a high school looking to get into a robotics competition, this solution is we're a strategic partner with FIRST for the FIRST Tech Challenge competition. So this set is used within that competition, and then within Skills USA, the Urban Search and Rescue competition, the Tetrix Max is also used in that competition as well. So thinking about the breadth of what the solution can be used in. One other thing to call out with every Tetrix Max, you get a license for our Tetrix virtual robotics simulation curriculum. So it's a coding curriculum intended to introduce students to very step-by-step coding practices, introduction into C from a simulated environment. So the students will work progressively through different tasks. They'll test their code in a virtual simulator, refine their code. Once the simulator verifies that the code is accurate, then they can take the code and actually physically run it on the robot. So there is curriculum that comes with the Tetrix Max. One single license comes with each set. In kind of addition to that, there's some wraparound curriculum to kind of broaden what you can do with it. So depending on the type of class that you're wanting to use it in, if you're wanting a purely coding focus, the Tetrix Virtual Robotics and the Coding Essentials would be curriculum. If you're wanting to add an engineering component to it, you can do a combination of incorporating the engineering mobile robotics curriculum to help get students familiar with how to build the system, how to put systems together, how simple machines work to complete a prototype of a robot. So that they develop that level of understanding, and then you can move them into the coding curriculum where they see how that microcontroller and the coding then power the robot to complete different tasks. So you have a little bit of flexibility with how you implement this.
Well, and one thing I would want to point out here too is just that I am so impressed by how thoughtful Pitsco has been with making sure that there's a progression, right? And so that's certainly what we're capturing here. We're going to continue on with that, but it's not just the device, it's not just the solution. It's okay. Well, here's this context, and then in the engineering context, and then as you progress in those skills, here's the next solution, right? And so that's kind of I would encourage people that are tuning in right now to certainly view it through that lens of it, that there has been intentionality allocated to that I think is really great from an education standpoint. So sorry, Steph, if I kind of interrupted you a little bit, but we can head right back to it.
No, and I mean, you said it. We want to make sure that the way that we're providing the options for implementation are very flexible, so that if a school is already doing something, but there is a need or a gap, that there's a way that we can come in and help support that. And so was really our mindset when we were kind of putting this together for what could be the potential needs of a classroom wanting to use these solutions. And then the other kind of curriculum piece is the competition in a box. What we've started to see is a lot of schools wanting to bring that competition element into a classroom setting where students are building and learning and gaining skills on the different robotics competitions. And so we've developed a package that would help them be able to build out a prototype or a model of a course, and then curriculum that goes alongside of it. So again, it goes back into that engineering side of it, because we know they have to design and build a robot in competitions. And then we also know there's autonomous pieces to it, so that coding side of it. So it brings in a lot of the challenges and open-endedness of the students have gone through, they've learned the foundations and the fundamentals. Now they're ready for the application. And so that's where this competition in a box really supports, is if that is kind of the intent or the objective of the class is to get kids excited or prepared for competition, then they have a curriculum to support that as well.
And Steph, I'm gonna bounce back off of what you said. Even with those curriculum packs, there's career connections included within each one of them, and so it's really tying to real world situations and real world scenarios as well, which is huge for any type of student. But whenever you can tie your activities and what you're doing in the classroom to a specific career, it's effective. And so we've included those career connections within the curriculum packs as well.
Yep, great call out, Preston. And as far as like what languages the kids will be the learners will be working in, is the Arduino C IDE is the language that they'll be using when they're in the coding application side of this. So again, an industry standard software that they're going to be learning the foundations of, getting experience in, and really the application of what does this all mean, and then how does it actually apply in a real world scenario to complete a task.
Yeah, and two questions I have real briefly then would be one, when we talk about careers, Preston, what are some of the ones that are mentioned in there, just to kind of help frame that for people that are looking to, because that's such a big thing in the classroom, is always frame the why, right? Like, and so, because you could become a coder, and yes, that's true, but you can be a coder in different career fields, right? In different professions, I guess, right? Is that where this is going?
Yeah, so some of the careers, and Steph, you can kind of help me out here, but like mechanical engineers, manufacturing, traffic light operators, things along those lines. There's a lot of different careers that are explored, but it's all around that mechanical and that kind of that electrical type focus for sure. And especially in the manufacturing space, we know that a lot of things are going to automation, and this really kind of just lays that foundation for those types of exploratory types of scenarios within this curriculum. So.
Yeah, and the competition in a box also brings in project management, marketing, and a little bit of the business side, because projects are a part of all the robotics competitions. And so, while yes, there's the technical side of it, we also know when we think about careers, technology is touching all facets of, a basic level of understanding and of how things work. To be able to sell it, to market it, to develop a project schedule, you have to have a little level of understanding. And so they touch on those careers as well.
Well, I think that kind of brings me then maybe to my second question, which would maybe be to pose this to Nick. Where within what we do in the Nebraska classrooms, and maybe even outside of it, because I will say that, on previous recordings, we even suggested that there might be after school clubs. And if I'm hearing about this competition kit, maybe that's a place where students can get exposure. But what are some of your initial thoughts as we're kind of exploring this particular solution?
Well, excellent. Thanks for including me here. I'm looking, I've taken notes while we're talking. I'm looking at 3 different opportunities. I know across the schools that we serve, we do have some standalone robotics or coding classes that these resources could be directly implemented into. And so certainly there directly. Another idea, just as you just said, I know that of maybe a quarter of our schools are engaging with the Skills USA work. And I think it's awesome that these resources are directly called for in some of those competitions. Lastly, ESU5 here, we do house a robotics competition. And so that happens mainly as part of like a club inside of different schools, or potentially even as makerspace experiences, kind of just set out and allowing students to explore these things inside of media centers. We do intend to incorporate specifically your drones into our robotics competition this year. These are wonderful resources, and one thing that I appreciate is that you do have curriculum that is flexible to be included or incorporated directly into a class, maybe on robotics or computer science or the like, but also is kind of open so that students could explore it maybe more independently in a media center or makerspace experience.
Thanks.
And I love that you're mentioning that kind of independent opportunity to learn, because I think that segues perfectly to what we're going to be able to check out here next. And that's some of these professional learning resources, because let's be honest, if you're a classroom teacher and you don't know anything about coding, or you're someone who maybe Arduino, that language is not something, your expertise is in another area. How are we going to go about kind of onboarding and feel comfortable with supporting students as they work with these resources? And so, can we talk to a little bit about what's out there in the area of professional learning?
Yes. So we've also included the e-learning courses that we offer to support the Tetrix ecosystem, meaning the RC. So that would be more of the engineering lens of the Tetrix solution. So it's an e-learning course for teachers. It is once you log in and you have it, it's yours. It doesn't expire. So once you work through it the first time, if you ever need to go back and refresh, or if there's a certain area where you need a little help or refresher, you can go back in at any time. And so it can kind of be that on-demand type resource and support. We have that for both the RC, which again is more of the engineering, and then we also have it for the programming side as well. So both lenses of tips and tricks, getting the classroom set up, things to think about, best practices, any of those little nuggets that are helpful for teachers to kind of get up and going that first time, or to have as a reference, is included in those e-learning courses.
Are those teacher facing or student facing courses?
Those are teacher facing. Good question.
Yep. Mm-hmm.
And if I remember from previous webinars, at the elementary level, at least, I think we discussed that there were some student-facing resources that you could access through the site. Is that true of the secondary, these 9 through 12 options as well?
That's a great question. So for both the Tetrix, well, I'll speak to the Tetrix ecosystem itself. So Prime is that middle school that we talked about in the 6th to 8. Max is for the 9-12. We have a abundance of videos available that students can access. So if they're in design and they need to be thinking about a linear slide system, we have a video that kind of talks them through what are the important things to think about, doing some testing out, and giving some of the background of what makes a linear slide, and what are those kind of key things to be thinking about depending on what you're wanting to do. We have a very large repository of those videos that are student facing.
Excellent. That's incredibly helpful. And so, if you're looking for those resources, you can check that out, the site that's listed at the bottom of the page. And at that point, I guess, do we have anything else we'd like to say or ask regarding this particular solution before we pivot to the Arduino Education CTC Go? Then I guess we're going to do that. Let's go to the Arduino Education CTC Go. And so I'm going to go ahead then and bring that up on the screen for us all. And I'm not sure whether Preston or Steph would like to speak to this particular solution, but
sure.
Tell us more.
Yeah, absolutely. So the CTC Go, so when we think about the Arduino side of the solutions that are available, it's really taking the controller. So, with the Tetrix Max, you have the microcontroller that powers it. And what the Arduino does is it kind of takes that microcontroller and looks under the hood of what does it mean, and how do you make a control system that then powers something. And so that's a lot of what the students will be learning about with the CTC Go. So it's designed to teach creative technologies in the classroom. There's 20 projects that are really easy to assemble experiments. They're very small. The platform that the students will learn and have the lessons presented to them is a digital learning platform. So it guides the students through. Teacher has resources and is more of a facilitator. It's really focused. What the experiments and the projects is really about introducing students to the foundations of programming, the basics of electronics, inputs, outputs, and the difference between digital and analog technologies and serial communication. So they're really going to be learning all of those foundational skills of the kind of like I said, the under the hood stuff that happens in technology. There's 8 practical lessons. There's 6 guided projects, and then there's 6 self-directed experimental projects. So it really moves them into that open-endedness of design and allowing for really that creativity. Each CTC Go will serve up to 24 students in a class, and it uses the Arduino Education Learning Management System. Teachers will create classrooms, they'll register the kits, and then they can enroll the students. Once they're enrolled, once you're good, you don't have to do anything else. It puts students right into the classroom, and they can get started working progressively through the lessons.
Terrific. A question I have in hearing about that is, could you give me an example of one of the creative projects? What that kind of looks like specifically, I guess, that people can expect when they unbox that.
Absolutely. So a pinball machine. So they'll take, the Arduino boards and all the circuits, and then some small little plastic pieces and prototype a pinball machine. There's also another game, like a speed game. If you think about like Bop It a little bit, like who presses the button the faster. So there's some games in there. And then there's a couple that involve vehicles as well, like small little vehicles. In it. So it kind of provides a broad spectrum. There's also some applications around energy and energy sources as well. So they try to cover a few different lenses, again, of the real world applications. Where are students going to see this? Where would devices like this be used to help improve something or innovate something? So they really do bring that real world application in when they're talking about those open-ended projects and experiments.
A question I have then is, as this sounds like one of the, if not the most advanced option in the catalog, would you say is, and maybe this is tough, right? This is in education always, how long does it take to learn something? Like, well, that's a great question, but it's different for every person. But generally speaking, what is the onboarding time frame that someone could expect to getting to a place where they're able to, we obviously looked at there were middle school solutions that were designed as to be a forerunner to this. But let's say that my child, as a freshman or a sophomore, would like to get into this. Is that something? How quickly do folks typically move through these?
Sure, and that's a great question. And Arduino does a really nice job of taking them step by step and progressing them at a pace, regardless of where they're coming in at. So if you're a beginner, the support and resources are there. If you have more experience, you're able to kind of grow at your own pace. So really the onboarding is relatively easy from the standpoint of, once a teacher creates a classroom, there's webinars, there's videos, there's lesson plans, all right there for them to know, here's what my students are going to be doing. Here's the questions I can pose to them. Here's the videos they're going to be watching. And the same thing for the students. Once they're enrolled in the class, they go to that first activity, and it's step by step. Here's how to get started. Here's a little bit about what each piece is that you're going to be using for this particular project. So Arduino has really done a nice job of a very easy entry with a very high ceiling as far as what the students can do, and also the support for the teachers as well.
Awesome. And we will probably have to draw it to a close here shortly, but I do want to ask Nick, as someone who wears multiple hats at ESU5, both as a technology integrationist and someone who supports teachers with that tech integration, obviously. And then I know that you also jump in and substitute teach or teach at times, so you're still in the classroom on a pretty regular basis. Knowing that those kind of resources are out there, I guess speak to your reaction to that, I guess.
I guess I appreciate that there is such a robust infrastructure around the product. And so what I hear you say is that the teacher can create a class, right? And then have students enrolled in the class. And now students can then move semi-independently through the content. It doesn't necessarily require that the teacher's an expert in the content, because the content will help the students explore and progress. And so when I think about that in the districts that we serve in the state of Nebraska, certainly I think about those classrooms which do focus on computer science, certainly. Although I also think about are future-ready librarians in the state of Nebraska. Potentially, then, instead of having an individual student identified as a seat in that learning management system, it could be kind of a bit more open. This is student 1, this is student 2, and now as students are able to come into the library and maybe have some time, that might be an opportunity for them. Another idea I thought about was across our schools, we have different variations of study hall or of resource or IEP or these shorter experiences, maybe 20 or so minute class durations. Well, if students, you might have an educator in your school district who feels like they'd like to take this on. I think it'd be awesome to house that in one of those rooms and build kind of a club experience around it. When students aren't engaged in working through whatever homework or other things they might be doing in that study hall, they'd have something that, I mean, I promise they'd look forward to playing with it.
Sure. Yes. And kind of on that note, Nick, we've also seen some classrooms that are wanting to bring like the physical coding into it. And so they'll do half a section if it's a semester with the Tetrix Max and the coding side of it from the mechanical side. And then on the back end, they'll say, hey, you know, that microcontroller that drove this, now we're going to learn about that. And so then they'll flip and they'll do Arduino for the other 6 or, so weeks of it, so that students are kind of seeing both lenses of how coding, mechanical engineering, electrical engineering, and how everything kind of works together, and not, this isn't in a silo and this isn't in a silo, but really you have to have this in order for this to work as well.
And it's both Arduino, so it works together really well in that regard. So,
Yes.
Well, I got to say thank you all so very much for your time today, as we've got the opportunity to explore some of these high school options from the catalog, solutions from Pitsco. And so one more time before we finish today, I'm going to point folks to our support site and also encourage you to reach out to Pitsco reps for the support that they provide in terms of like asking questions about things like unboxing your device, or really kind of onboarding students with that. And if you need any tech integration support, the ESUs have you. So make sure you reach out to your local ESU, to great educators like Nick, who will be more than happy to support you, your teachers, and the students in making sure that these solutions meet the Nebraska classrooms. And so thanks, everybody. One more time, Preston's going to be at Spring Nita.
Yeah, good 509. I'll be there all day, every day during the conference. So if you have any other questions, don't hesitate to come by, say hello, and hang out for a little bit.
Well, I'll see you there.
Yeah.
Hey, me too. So thanks, everyone. And make sure you check out the other videos in this series.